All right, so here we are with number 25, still solving the equation. So let's go ahead and rewrite the original equation just below so we can start to figure out our common denominator. And again, you'll recall, especially if you've been watching the previous videos, that we want to find a common denominator. And once we find that common denominator, we're going to multiply the entire equation by that common denominator so that we can clear the fractions. We don't want to work with fractions, right? We're trying to solve this equation, and so we want to solve for t, and the easiest way to do that will be to get rid of these fractions and set up a more simplified algebraic expression that we can simplify to get some sort of solution. And we know that and you know what, I made a little mistake here. This is t squared minus 4. T squared minus 4, t minus 2. All right, let's go ahead and factor each of our denominators, and that'll help us to determine what the actual common denominator is going to be. And so in this case, t squared minus 4 you will recognize as being the difference of two squares. So that factors into t plus 2, t minus 2. And again, difference of perfect squares here, t plus 2, t minus 2. Here, this t minus 2 can't be simplified, and so we have our t minus 2. And we know that the common denominator has to have one of each factor that's unique. And it looks like we're only dealing with t plus 2, t minus 2. And yep, that's it. So we need one of each thing that's unique. So our common denominator is going to be t plus 2, t minus 2. And I'm going to write that above each of our terms here. T plus 2, t plus 2, t minus 2. And if you don't like writing it above each individual factor, remember you can go ahead and put parentheses around the whole equation and then write t minus 2, t plus 2. Of course, without, you won't have these individual written factors out. You'll just have your set of parentheses and then one time write the common denominator. But this is the same thing as saying multiplying the whole equation by that common denominator. I just happen to like writing it above each term so that I can go ahead and cancel visually what factor I'm getting rid of. And I think that'll make a little more sense here in a second. So let's go through and actually start our multiplying. Let's see, t plus 2 cancels. T minus 2 cancels. So we're left with just 5t plus 9. 5t plus 9. Equal sign comes down. And again, t plus 2 cancels. T minus 2. And so we're left with this entire trinomial, negative 2t squared plus 5t minus 1, and t minus 2 goes away. So we're left with t plus 2, that quantity, times the quantity 2t minus 4. So let's see what happens. Let's go ahead and FOIL these two binomials out and see what we're left with. So t plus 2, 2t minus 4. Well, t times 2t gives us 2t squared. T times minus 4, minus 4t. 2 times 2t is plus 4t. And we have 2 times negative 4 is minus 8. And so 4t, one's negative, one's positive. They cancel each other. So here we're just left with, this is a positive 2t squared, so plus 2t squared. And here we have a negative 8, so minus 8. All right, let's go ahead and combine some like terms and see what happens, shall we? Let's see, negative 2t squared, positive 2t squared, well, that goes away. We have 5t and no other t's, so that'll come down as 5t. Minus 1, minus 8, we get a negative 9. And so let me bring down 5t plus 9 comes down. Let's go ahead and try to get everything on one side of this equation, and then look what happens here. So if we try to get everything to one side, we'll go ahead and subtract 5t, We'll add 9, Well, in this case, when we end up trying to get everything on one side, 5t's cancel. We end up with, well, 9 plus 9 is 18. But here on the right-hand side, 5t minus 5t goes away. Minus 9 plus 9 goes away. And so we're left with 18 equals 0. Well, that's kind of weird, isn't it? 18 equals 0. Is that a true statement? Does the number 18 equal the number 0? No, definitely not, right? That's a false statement. And so in this case, the answer is, you could just say no solution and move on, because what this is saying is that there are no values that you could plug in for the variable t and get a true statement. And so since there are no variables, there are no values or solutions, we can't give them any. And so we say no solution. And that's it. Nothing else we can do. All right, well, that was number 25. Let's go ahead and take a look at number 26. This is Joe Brownlee with Palm Beach State. Thanks for watching.